Welcome back to Soils 446, Soil Fertility and Plant Nutrition. Today I'll be talking about module number 4. In this module we will be talking about ion exchange. Basically, soils are composed of three forms of matter: the solid phase, the liquid phase, and the gas phase. And today I'm going to talk about the solid phase. The solid phase is very important in soil fertility and is composed of organic material, what we call the humus, or the inorganic material, the clays in the soil, and the organic matter, which we call humus or organic matter. So two components to ion exchange: inorganic material and organic material. So I'll be covering material that you learned in introductory soils and introductory chemistry classes today. This is basically a review. Cation exchange capacity is primarily composed of clays, organic matter, and the small silts. Generally, the more clay, the more organic matter a soil has, the more cation exchange capacity the soil has. Because cations are positively charged, they are attracted to surfaces which are negatively charged. And organic matter and clays are generally negatively charged, so positively charged nutrients such as potassium, calcium, magnesium, and ammonium are attracted to these negative sites on the clays and the organic matter, and that's what basically holds these nutrients in the soil and makes them available for plant growth. There are two very important terms that we'll be using the entire semester. These terms include cation exchange and cation exchange capacity. First, if we take a look at cation exchange is the interaction between a cation in the soil water and another cation that's on the surface of any substance, such as clays, organic matter. It's active materials such as clay or organic colloids. Secondly, a term that we use oftentimes in soil testing is the soil's cation exchange capacity. This is often abbreviated as CEC, and the cation exchange capacity is the sum total of exchangeable cations that a soil can absorb. Basically, the sum total of negative sites in a soil, and that's comprised primarily of clays and organic matter. We measure that and we express that in milliequivalents per 100 grams of soil, or more commonly MEQ per 100 grams. It's a term we see all the time. A lot of soil test reports express CEC and available nutrients in this terminology: milliequivalents per 100 grams of soil. Important factors that influence ion exchange in soils include basically 5 things. First of all, the amount of organic matter present. Basically, the more organic matter we have in a soil, the higher the CEC of the soil, because organic matter has lots of negative sites. Ion exchange is the amount of clay present. In general, the more clay in the soil, the higher the CEC of the soil. And remember, both clay and organic matter have negative sites, so as you would suspect, the more organic matter, the more clay, the more negative sites, and the higher the CEC of the soil. The third factor affecting ion exchange is the type of clay that's present in the soil. We have different types of clays in soils. We have some clays that don't have a lot of negative charge. We call them low CEC or low cation capacity clays. They include clays such as kaolinite, illite, and hydrous oxide. Conversely, we have some soils have clays that have lots of negative sites, and we call these high cation exchange capacity clays, and they include the clays that we know as vermiculite and montmorillonite. The fourth important factor that affects ion exchange in soils is the pH of the soil. We find that with soil organic matter, which has negative charges, the higher the pH of the soil, the greater the CEC of the soil. And that's because organic matter has what we call pH-dependent charge. At higher pH values, there are more negative sites associated with organic matter than at low pH values. From a management standpoint, in very acid soils, sometimes we lime soils to increase the CEC of the soil to make it hold more nutrients. And finally, the fifth important factor that influences ion exchange in the soil is actually the concentration of ions in the soil solution. What is the concentration of nutrients in the soil water? The concentration of nutrients in the soil water influences ion exchange, but has no impact on a soil's cation exchange capacity. It's important to understand that there is a general relationship between the soil's cation exchange capacity and its ability to support plant growth that I'll show you in the following graph. Here we have a generalized graph. On the x-axis, we have the soil's cation exchange capacity. To the left, we have a low cation exchange capacity, in the middle, a moderate cation exchange capacity, and on the right, a very high cation exchange capacity. On the y-axis, we have relative plant growth. On the bottom, we have poor plant growth, and on the top, we have good plant growth. Excuse me. Well, there is a general relationship that as the CEC of the soil increases, we get better plant growth. As you can see over here on the left side where the CEC is low, plant growth is only moderate. As the CEC increases, plant growth becomes good. So when we have moderate and high CECs, we have the potential for pretty good plant growth. Basically, we have this rule of thumb that if a soil has a CEC, a cation exchange capacity, less than 3 milliequivalents per 100 grams of soil, the lack of negative charges in that soil may actually limit the soil's ability to hold nutrients. CECs are low in sandy soils. So it's sandy soils, loamy sand soils, where the CEC may be so low that it may have a dampering effect on the soil's ability to hold nutrients to produce good plant growth. And we'll talk about this a little bit later.